So today we are going to design an entire e-commerce platform like Amazon and eBay. And we will be doing high level design, low level design, data design, API design, and understand that how you can design a complicated system like this, put everything on the map. So this is going to be a very in-depth review on the system design front, and I want to put my utmost attention because this is one of the most popular system design interview question. So this question can be asked in 10 different ways, but answer is going to be very similar. So what we are going to be doing over here, let's understand the functional requirements first. These are the requirements that we are willing to tackle in the actual interview process, and I have taken a lot of functional requirements, but you can dumb it down based on your discussion with your interviewer. So first of all, we want to have users to be able to use and access our e-commerce platform. So user should be able to create an account, they should be able to authenticate themselves, there should be different profiles that they should be able to update, and there are going to be roles about buyers and sellers, and then there are going to be management that can be done about the users. Also, this user management system would be used by other systems later on that would identify that who is the user that is currently purchasing this item on our system and whatnot. So this is an important one. Okay, next one we have is product management. Because it's an e-commerce platform, Amazon runs on products. So we are going to have hundreds of or thousands or millions of products being able to be listed on our platform. User should be able to, or seller should be able to create those products and then edit and categorize the listings. And there are going to be inventories that needs to be managed as well. So we will do all of those things through our product management. And then user should be able to search for different products. We also wants to have full text search capability. We also wants to have like some auto suggestion capability. And then searching can happen through various sort of filters. So filters such as what is the pricing looks like, what does the brand, what is the rating, what is the relevance, different sorting options. Maybe some items are seasonal, some are promotional, and things like that. So all sorts of features should be there, and user should get try to get like best experience. Plus, if user makes some sort of typo, we still want to show them the current product and associated products with that. So how can we take into consideration about all of those things? Next, the moment user can browse the items, they can search for different items. If they like something, they should be able to buy them. And in order to buy them, there should be the capability of adding the items to the cart or removing the items to the cart. So of course, we need our shopping cart and checkout mechanism being set up, where you can add and remove multiple items. You can buy items in small and large quantities, and if there are any promotional coupons, loyalty customers, or things that are running, they should also get discounts based on that during our checkout process. So this is also a very important requirement. Now whenever user is checking out for things, then we should be able to create orders based on their checkout and collect payments for the things that they have purchased. Also, if something goes wrong, we should also be able to return the items and get the refunds, provide the refunds to the users. So this is also important functional requirements. Next, we want users to be able to review and rate the things, and then based on those rates, other users should also be able to see those ratings so that they can make their purchasing decisions based on that. And then we are going to have seller analytics. I have only noticed seller analytics over here, but there are going to be all sorts of different analytics that we should be able to do. There can be analytics based on how the system is behaving. There can be analytics on how many products are we selling. There can be analytics for executives. There can be analytics on what should be the new market we would be exploring, or how seasonal promotional is working or not. So there are a lot of analytics that goes into understanding that how the whole system is going to run. So, and then there are many instances where we can notice that notification needs to go there to the user, whether to authenticate them, whether to send them promotional items, whether to send them updates on their order, or just for all sorts of different activities. Something happens with their account, we want to notify the user that hey, there has been this change, or you have purchased this item. Notification can go into via SMS, email, or in-app notification, and it can be for all sorts of things. So any other service can use the notification service to send out notification to users. So these are our main functional requirements. Now let's talk about non-functional requirements. So of course we want our system to be scalable. During high traffic season and high traffic areas, our system should be able to behave as expected. Then it should be reliable. So currently we are aiming for 4 nines of availability, which is decent availability. And if let's say the failure happens, we should be able to gracefully fail them, which means it should not be the scenario where if one system fail, now our entire e-commerce platform is dead because we can't access the functionality. So we will try to have that loosely coupled nature available within our system. Then performance. So of course, where performance matter, things like fast page loads, quick searches, smooth checkout experience, all of these things we want to make sure that we have like being done as smoothly as possible. And we want to be mindful of security and compliance issues, because we are dealing with people sensitive data and their credit card and debit card information payments. So we have to be compliant with different government agencies. We should be able to maintain our system and make sure that how we can leverage DevOps, DevSecOps, monolith versus microservice, and how different microservice would communicate with each other, how the data is going to be living at different places, and how it can be accessed by some other service. So we will talk about it during our high level and low level design. And then there should be appropriate logging and monitoring mechanism and alerting system. Plus we would also want to make sure that because things cost money, we want to be mindful that how can we improve performance at the least increase in the cost. These are our functional and non-functional requirements. Now we will understand the high level design. Now I'm doing things slightly bit differently. First, we are going to walk through every single functional requirements and create appropriate microservice and its appropriate database. After doing that, we will create like a larger entire architectural diagram that is going to combine every single thing, that how different services interact with each other, what are the constraints, how the data would behave and things like that. And then we would go into the realm of low level design, where we would go much deeper at each service level, that what does it mean, what the API should be, and what the data design should be, and things like that. So it's going to be a very in-depth system design oriented discussion from an architectural point of view. And again, I want to keep it as detailed as possible, so that's why I would be spending a lot of time, and this video is going to be pretty long. But in the interview, you need to pick and choose that how you want to proceed, so it's again up to you. So now let's start with the high level design. Okay, so now we have our requirements outlined over here. We will go through each of these requirements, and we will create appropriate necessary set of microservices and their associated database. We will also understand that why are we choosing or picking each of the database. And our first requirement is user management, that user should be able to create an account and they should be able to authenticate themselves, and there are going to be separate profiles and role management that we'll have to take care of. This all can be achieved with a simple user services that is going to have a relational database or a user DB on its own. On top of it, we would need to constantly generate JWT token or authentication session tokens. This can be done within the user services, but then it is going to increase the scope of overall user service. Plus, we may need to ship out this functionality in the future. So that's why I have created a separate authentication service, and the combination of all of this is going to be a user management module. Now most of the systems, if they wants to generate or access the authentication tokens, we are going to publish REST APIs that would be living within the user service that would call these authentication services behind the scenes. So overall, this is going to be our user management module. Same way, we need to maintain the product management. So we should be able to create, edit, and categorize the existing listing. Plus we need to be able to manage inventory. So we can do this using a product catalog service at a very large scale. And for that, we are using a NoSQL DB, that is going to be our product DB. Now, why are we using a NoSQL DB over here? Because of this categorization of the listing. Imagine for any particular number of products that would be listed in our application. It can range from like TV and fridge all the way up to a t-shirt and pen, and each of them are going to have a lot of separate attributes that we need to take care of. And that's why a strict relational DB would not be the best choice in this case. We can still make it work, but ideally a NoSQL DB is more sensible for this kind of data storage and fast retrieval access, where we can attribute values and create separate categories based on many different criteria. Okay. Next, we need to have the functionality of a search and browse. That user should be able to do a full search and categorize based on their listing, and they should be able to see all sorts of different results and different lists based on like relevance, price, brand, sorting, and things like that. So for that, we can actually do it using a simple search service that is going to speak to a database. Now this is going to be a special type of database. This is going to be an Elasticsearch DB that is specifically designed for optimized search queries, that it is going to work on a large chunk of products and be able to quickly sort through based on different index positions and index values. And that's why we are choosing an elastic DB over here. Okay, next requirement is shopping cart and checkout. Now we need to be able to add and remove items in the shopping cart. We need to be able to apply quantities, and we have the ability to pick and choose different coupons, discounts, and things like that. So I have created a carts and checkout module where we are going to have a simple shopping cart that we should be able to use. On top of this, having simple shopping cart service, that is going to have a carts DB on its own, where we would have all the information related to any particular cart ID. That, let's say a user has created a cart and then added these 10 products, we can store all of that information very easily in a SQL database. Now along the same time, for any particular transaction, user should be able to apply promo or discount codes that they have, and we need to manage them separately. So that's why, once again, just like authentication, we are going to be creating a separate promo service that is going to have a different DB of its own. But overall, if we have to access this promo service, we are anyways going to do it through shopping cart, because all the checkouts would happen through shopping carts only. You cannot directly check out products before them being added into a cart. So that's why this level of slight coupling between these two services makes sense. Next is a very important one, that is ordering and payment functional requirements, where a user should be able to create orders once they complete the payment. For payments, we need to charge their credit card, debit card, wallet, third party application, PayPal, Stripe, whatever. And if something goes wrong, or user does not like it, or we don't have the product and we overcharge them, we should be able to do a refund, or user can choose to do a return and then collect the money back. So in order to accommodate that, we need a dedicated payments module. This payment module is going to contain multiple services on its own. And first one is a wallet service. So remember, because this is an e-commerce service, now you can debate this with your interviewer whether you wants to create a service where user should be able to do just one time payment only. What do I mean by one time payment? It's whenever you go to checkout page, you don't actually need to save your credit card. You can just directly enter the details, and then the system would charge your credit card once. That is one option, that is called one time payments. Or you can do a stored payment, where a user is dedicatedly being asked that whatever payment methods you have, you need to store that before we charge your services. So for those stored payment kind of services, we are going to be storing their wallet information. Now this wallet can contain their credit card, debit card, American Express, PayPal, or different loyalty programs. So each of those, we would that would be living within the wallet services. For the payment services, this is going to be our main payments engine. So this would contain information that, hey, I want any services can come to this payment service, and should be able to say that if I want to charge a user this much amount of money, how do I do that? Then our session would be created. Payment service would be able to collect the wallet information from the wallet services and charge that credit card based on some third party integration or local integration that we have. And if we go and pick and choose third party payment system over here, then we can also offload our PCI compliant requirements as well. Because remember, that is one of the key important pieces, that whenever you are storing the credit card, they all the information needs to be encrypted. And if you are charging the amount, how you are going to be storing those payment tokens that go back and forth between the bank or your charging mechanism and your actual payment service. So we can also do that over here, and that integration would once again be driven by the payment service system. So overall, this entire payment module is going to be controlled by payment services, where it is going to be able to speak with the wallets and so on and so forth. And apart from payments, whenever payments gets processed or done, order needs to be created for that particular item or cart id, and that's why we are going to have a separate order services that is once again going to have a relational db, that is going to be orders db, that would contain all the important information, that what is the order id and what are the things being associated. So I hope you understood what we did with the payments module. And then we have a simple reviews and rating services. Now user should be able to review bunch of things, and they should be able to provide their ratings. So we are going to have a reviews and rating services, and in this case we are only going to have a relational db to store this information, because it's quite straightforward, not very complicated. Now we comes into the realm of analytics. So sellers wants to know what are the analytics with their sales. We also wants to check analytics on our own. As a system, we want to know that how many cards are being left abandoned, how what has been the user behavior, how many amount number of things that we sold out, and what has been the inventory looks like, and n number of things we can do. We also wants to generate like quick reports that whether the services are functioning as expected or not. All of these things can be done on the live db, but it's not recommended. Why? Because live db is anyways being handled, and we need to leave it as isolated as possible. We don't want to overburden it with something separate. So that's why we are going to have a data warehouse, where we can have like nightly sync jobs, or maybe like every 6 hours or every 12 hours we dump all the data from the main live db into the warehouse, and then all the analytics that we need to do, we can do it on the data warehouse db based on like analytics db. So that's why we have like we can have a huge data lake house, or we can use databricks, snowflake, any different technology to generate these analytics, and then we can show them using power bi or tableau or whatever tools we want to do. So that's why we have a separate analytics service as on its own. And then we will have a notification service. Now this service would be used on n number of different things. Whenever we wants to notify user about something mass new marketing promotion, we can use notification services. Whenever we wants to notify a user whenever a significant event happens, so let's say a user decides to buy something and the payment goes through, we want to notify the user. We want to send them out an email about their payment has been done, or the order has left for shipping, or their order has been delivered, and we want to do an in-app notification or an email notification. So for all of that, we are going to be using a simple notification service, and once again it can be easily accommodated by sql db that is going to handle all these things. Now this is just the tip of the iceberg, that we have created bunch of different separate applications that we know that okay, they are there to serve these functionality, and I have consolidated everything closer to each other. And now we would be doing our favorite part, that is drawing bunch of arrows and explaining that how the entire flow is going to work. Also, just a quick understanding for our notification service. So since we are planning to use a pub sub model, I have put a Kafka event subscriber on before that. So notification service would be subscribing a lot of the events and then publishing it out to the different users, and then we can work around the flow about that. So now let's just understand from the very basic point and very start point of this whole system, that starts with you. So the user is going to be the person using our system and interacting with it through some browser or mobile application. For simplicity, I've just kept browser over here, and then through browser would be speaking with a WAF. We want a firewall outright outside before all of our system. So any of the internal apis must be only be accessed through internal portal only and through api gateway. We don't want to have direct access, neither we wants to have any sort of microservice speaking directly with the database of some other service or something like that. Entire communication would be api driven, and we would be using api gateway in order to accommodate that. So we have our user calling browser, calling firewall, and then firewall is going to be speaking with API manager or AWS Manager or APG, Akana, anything you want to put it over here. But basically, it's going to be an API gateway handling all the communication. Now, first we have our users database. This contains all the information about the user. So whenever user first visits our site, they should be able to create an account, log in, register themselves as a buyer or seller or whatever they wants to do. So of course, there is going to be a functionality being associated with that. But at the same time, not every single user using our system would actually be interested in creating an account. They might be just looking for that direct purchase that they want to do. So how we can accomplish that? So for that, we actually have our search index system available. So this is going to be the system where they should be able to search our products. So of course, the user is going to have that functionality to do that. On top of it, they should also be able to just browse the products, and when the time comes or whenever they are working, they should also be able to just have a feed available to them, because many people would be just visiting our site just out of curiosity and then see that what they have to offer. Or we need to have like a product timeline or list of categories of product that popular items are should be built around for them. So there can be some additional curation we can do at the product level in order to accomplish that. On top of it, if someone searches for the product, then they should be searching with the product based on existing product catalog we have. So in that case, our search service is actually going to be speaking with our product catalog service, and then they can communicate and decide that what is going to be the database. We are not providing direct access to the search service, but because this is Elasticsearch database, we are going to be doing a lot of precursor work, and there is going to be a lot of internal server side sorting and indexing that we would do on our database, so we can quickly start looking a product. Like if you try to understand the example of Amazon, it is somewhere over like 30-40 million products. Imagine that when I start searching something and then it has to go through the entire DB of those 40 million products, it would never work. It would be very inefficient and I would lose interest before I start searching for the product. So that's why we are going to have a purely curated list of products being available based on popular search query results and just server side indexing that we have done, and then there is going to be that communication. On top of it, because users have access to buy products and users are also going to be able to sell products as a seller or as a business, then our user DB also needs to be speaking with our product catalog DB, so we can have a connection like this over here. And same way, any user who is going to buy any particular product, we want to make sure that we have authenticated that user, and things goes vice versa. So that's why I'm just adding one more arrow over here. But basically, this is going to be a two-way communication, and I hope this makes very clear understanding. Now let's come back with our product catalog. Any user who purchases the product should be able to review the product, right? So of course there is going to be a review section, and at the same time users should be able to see reviews and make modifications and do all sorts of changes. So let me just, because this is close by, let me just first create a connection that users would be able to. So in order for any review to be published, we want to verify that who that user is, and whenever the product, like for which product the reviews were being created, and based on the reviews we can also have our sorting algorithm and update our search query index as well. So we can also, if we want to do it, we can do it, but this is something that I would highly recommend that you discuss with your interviewer first before doing that. Okay, now let's just zoom out a bit and then realize that what else. So let's go back to our previous flow that we were discussing, that hey, you come in as a user, you have the access to create your account. Let's say you created account or you did not created an account, you started searching for the products, and then you started looking at the bunch of different product catalogs. You search them based on your own criteria and things like that. So far we have used like a decent chunk of portion of our system. At the same time, if I like something, of course I would like to be added to a cart, and then I'm going to be using the cart service. So what this cart service is going to be about now, there are two things associated with the cart service. I should be able to add products to the cart just as a normal guest, but I want to block the functionality that I should not be able to check out without having an account. We are only going to allow checking out for those users who have already purchased, who have already logged into our system, or who have completely registered and who have validated their accounts. Because let's say that you allow guest checkouts happen, there is a potential of fraud, because anyone can create fraudulent accounts that we haven't verified, and we can run into all sorts of issues. So we want to block that functionality. So that's why, of course, whenever you are browsing the products, you should be able to create any number of carts you want to, and add those products and remove those products. But at the same time, for in order for any cart to be checked out, it has to be associated with the user. So we can just discuss this with our appropriate team member as well. And then this can give us an idea that, hey, how many carts are left abandoned, how many carts are sitting idle, how quickly user is adding items to the cart and then getting those things out quickly, and then purchasing them. And then we can find all sorts of meaningful information from that data. So this is like really critical information. And then through carts, whenever you want to finalize a product, then you would be drawn towards the payment services. Now for the payment services, of course, we have three main items that we need to worry about. Number one, our payment engine. So this contains all the information that you want to buy a new thing, you want to ask for a refund, you want to do a split payment, you can do all sorts of things with that. Then we are again limiting the functionality that you can only be purchase items that you have done with your stored payment. So our wallet service needs to have our stored payments, and that's where the payment service also needs to speak with our basically our DB and our authentication services. So let's just provide that connection. And at the same time, we are going to have our payment service do its thing and have the third party system run. So we are nowhere else is touching it. So now notice that our payment service only gets called in when we try to be in the checkout flow. So when we have browsed through the products, we have added products to the cart, and then through the cart, now we are ready to make the payment. The moment payment is done, we should be triggering a call to the order service, because now the new order needs to be generated. For this new order to be generated, we want to have the completely consistent behavior so far, because remember, whenever we buy something, we want to make sure that the payment goes through. So that's a consistent behavior that we are aiming for. After that, we are also aiming for that whenever we create an order for some item, the order has to be part of the inventory. We mention that okay, for this particular item the person has already paid, and now let me go ahead and reduce the inventory. So I haven't mentioned the inventory management system over here, but you can just imagine inventory management system being like a sub part of this order services, where that is we may have a specific DB for inventory, or we can also have it part of the same order DB that is also going to be working with the inventories of different products, so on and so forth. Or if we want to make it like more elaborate, maybe we can have this inventory management system have an entirely separate block on its own, and then the user should be able to just go and buy all of those things. So this you can discuss with your interviewer, but I'm just mentioning over here that we will have an inventory management system work for us. Okay, cool. So now we have taken care of most of these items, and then our item gets done, payment goes through. So now let's see what else needs to be done over here. In this case, what are we missing, or did we took care of all the all the major items or all the major categories? Number one, user management, we already took care of it. Product management, we took care of it. Search and browse, we took care. Shopping cart and checkout, we took care. Ordering and payment, of course, we took care. Reviews and rating, we also took care of that. Seller analytics and notifications, so these are the two main ones that we haven't figured out. Now, which services should be calling our notification service? Just try to understand it. Number one, whenever let's say a user makes a purchase and the payment goes through, we want to call out our notification system. So that's a very clear, simple, like low hanging fruit. Okay, of course we can do that. Whenever an order gets created, completed, published, delivered, we also wants to notify our user, so we would be calling the notification service. Whenever, let's say that you have browsed some products, or you have browsed some projects, and there are some important cart information that we have notified. And then we realize that there are items sitting in the cart that are left abandoned, and now I want to target you for some important promos or something. How would I do that? So we can have like a cart service also be able to speak with our notification system that is going to be reaching out to notification. Okay, when you create your your account for the first time, I also wants to check that I want to notify you via email or application that hey, congratulations, you have created an account. Maybe I want to reach out to you. So of course user system is going to be associated with the connection system. Then what are the significant events that can happen that I want to keep track of and notify the users based on that? So let's see. I think for the product catalog, if there are some if I found some meaningful results where that okay, this product is available now and now I want to send it out to bunch of people and start making notifications that way, should I be doing it from the product catalog service? It doesn't make much sense. So of course we can do it through checkout services because that is like an extended version with more finely curated data. So we will keep it as it is now for now. Okay, and then we have our analytics DB that needs to get all the information. So what we can do is we can just say, because this is our data warehouse, and data warehouse is going to be combination of all of these things that currently deals with the database, and this data would be getting synced maybe through a nightly job or daily jobs within our system. So we can just have like a massive block over here saying that this is going to be our live production DB, and then this needs to be sync up or daily or with nightly jobs or with routine basis with our data analytics. And through that we would be making all sorts of different predictions and different items. So this is where we have okay, we have defined that how our data analytics would get populated, and then we can have all sorts of different ad dashboards and Power BI and Tableau and all sorts of services associated with that. So let me just quickly mention some Power BI over here. Uh, okay, yeah. So through analytics service, we can have our Power BI and all the reporting being done, and then we can create all sorts of important dashboards that we want to. Cool. So this looks like a decent enough diagram or a high level design for our e-commerce platform. So notice that we are taking care of every single functional requirements, but we are not taking care of non-functional requirements. So what were our non-functional requirements? Number one, consistency, scalability, availability, reliability, all the different elites. I could have defined them in the architectural diagram. It's just I didn't because I am still trying to figure those things out, that how I want to plan it out. So in the subsequent videos, we would put more emphasis on the non-functional part, because anyways this video is getting extremely longer and we are still yet to define low-level design and API design and data contracts. So I'll figure it out on how I can best teach you about the non-functional requirements. Meanwhile, let's move on to the next section now. Okay, so now we will delve deeper into the realm of low level design. So basically we are going to be talking about that for every single services that we mention, what does the typical API structure is going to look like, and what is going to be the detailed data model and schemas that we are going to be doing. We have some assumptions that we have already established, that is that no communication would happen directly with the DB. Everything would be communicated through API gateway. So we will just have it like as a common rule of thumb. And at the same time, when we are talking about low level design, I'm designing it based on something that you can cover in a 45 minutes to 1 hour interview call. Actual low level design would be much more complicated and way more significantly um, more comprehensive, but I'm covering enough that we brush over all the topics, and then we will just talk about bunch of things as we move along. So just as a quick reminder, these are the services we currently have different database for, and for each of these services, we have established that what is going to be their service name, what is going to be their database, and what type of DB there is. So it's there. I have explicitly mentioned it over here. Now let's move on to the next topic, and that is to understand that for each of the user services, what does it looks like. So first user service we have is the user service. This is being used for user typical user management. Their core responsibilities are that user should be able to register, user should be able to authenticate and create profile updates. Also, this service is very closely associated with our authentication services that validates and manages our JWT tokens and manages server side sessions. So we can either create like user sessions or JWT. If you are given a choice, always pick JWT because it's faster, it's less load on the server, and it can be implemented in relatively simpler fashion. So JWT is much better option compared to just for every single API call. If you have to call server to authenticate, then it becomes way more expensive in the actual implementation. Now let's see that what does a simple table looks like. So for our simple table, we are going to have a users DB that is going to be a SQL database, and for the table name, we need a user ID because every single user is going to be associated with an ID. Then you can debate whether you want first name or last name. I just put username just to keep it simple, and then we are going to have email associated with the username. Then we are going to have hash password, and then what is the role. So role is defined for whether it would be a seller or a buyer for that particular user. And then it would be when the user was created, if any updates were made, what was the last updated date and time, and things like that. So very simple data design. And in terms of APIs, we are going to have APIs to do all the important events that we just mentioned. So user should be able to sign up. So there would be an sign up API, then there would be a login API. Anyone wants to log in, they can provide their credentials and they can log in. And then there is going to be get user based on the user ID details, and then we can patch something with the user if we have to ever modify, or guest services if they want to change anything with that. So this is a simple low level design for our typical user service. Now let's move on to the next one. This is going to be the product catalog service. So we are going to have our database type as once again SQL DB in this case. We can also work with non-SQL DB, and I have chosen NoSQL for the simple fact that we are dealing with large quantities of data that has a lot of different categories, and it's difficult to maintain in a SQL environment. So there are some examples of Cosmos DB or MongoDB or something like that that you can use for this one. Overall, when we talk about key entities, we are going to be dealing with two main tables. First one is products. So they are the list of all the products that we have, and then it's categories, because we need to define based on categories as well. And there are going to be some interconnections between those two tables. So for products table, we will have our main primary key as product ID, and then we will have seller ID as the foreign key because it associates with our user DB. And then we are going to have name, and then description of the price, and then product and quantity and category ID, and when it was created and updated and things like that. So just one quick note over here, by the way, created and updated at is always going to be there no matter what. So just presume that this is there unless explicitly we don't need it for some scenarios, very picky scenarios. More or that you always wants to have that audit log capability, that when was this row updated or created. Then we are going to have our category table that is going to have category ID as the primary key. And notice that we are also calling category ID based on our products as well. So every single product is also going to have category that we can define on the category list. And then it's going to have what is the category, and then what does the parent ID means like, and things like that. So then we can have more nuances in our categories table. As core responsibilities of a product catalog service, of course, it stores product information and maintains the category hierarchy. We can sort things on all sorts of different manner, and it also maintains the inventory of the product as well. So remember that when we were doing the high level design, we mentioned that how the inventory would get updated whenever a user order gets created and things like that. In terms of sample APIs for this service, we will have our core products API, that you should be able to create products, then you should be able to get product details, then you should be able to patch anything with the products, and then you can also get categories based on different categories that you can provide. So things like that, pretty standard. Now let's move on to our search services. Now we are going to be using Elasticsearch over here for our search service, and this is going to be specifically a search index heavy database, because we are dealing with large amount of products and we want to do server side integration before we start making changes. First understand the core responsibilities. We should be able to search fully, so anyone type something, they should be able to search. Then it should also provide auto suggest, because that's a cool functionality to have and also really helpful in a lot of scenarios. Filtering, you should be able to filter based on what you are typing and then create different indexes based on that. And we should be able to update the index in near real time, because we wants to get as much results as possible. But at the same time, we should be able to do batch processing from the product catalog service when we are just doing it, so to make it more faster. In terms of entities, of course we are going to have our product ID that we would be calling, and then description about that item, that what are the keywords, what are the tag words that we can maintain, then what is the category of that particular item, and then what is the price, because we would be sorting in all sorts of different ways, so how to show those results. So that's why, see, all of these typical fields that we have, they are all associated with how can I quickly identify any particular product if I'm given a large chunk of different items. And then in terms of sample APIs, we can do like a search result query, and we can do a suggest result query. This is for auto suggest kind of feature. Next, we have our shopping cart service. So once again, this is going to be a purely a relational DB, because we want to have a long persistence layer associated. We can also use key vault DB if we want to, but I prefer persistence in this case, and that's why SQL DB makes more sense. We are going to have our cart and cart items table, and for cart it's pretty standard. We will have our cart ID and then user ID, because user would have created that shopping cart, and then what is the status of that shopping cart. If it is active, which means user is actively looking for some stuff and it has just been created relatively fresh. If it's abandoned, maybe it got created like few hours ago or few days ago, and then no one is looking at it. So then there are those features. Same goes for the cart items, that when was this cart items being added, what was the product, what was the quantity, and what was the price of that particular item when it was added. Because it could be possible that that I saw a cart item that was like, I added an item that was $50 when I added, but the price may have changed to like 55 or $40 depending on the different scenarios. So how do we want to notify that to user? And that can be a case where we want to send out notifications to users saying that, hey, this thing that you wanted to buy, now it's available at a cheaper price. See if it's only sitting in your cart, why don't you just go and buy it? So this is where these things comes in real handy. Responsibility is quite straightforward, maintains the user card state like items, quantity, subtotal, and then we have the APIs to add and remove all sorts of different cards. And these are the APIs that we would recommend, that we can create items to the cart, we can remove items from the cart, and we can get the details at what is currently present in any given cart. Then we have our order service. So order service uses a SQL DB for very simple purpose. It has to be completely acid compliant, and we should be able to maintain inventory and records of what order was being placed at what time. So we want to make sure that there is high level of consistency, and that's why we use it. We can have like multiple tables over here. There is that orders table and orders item table. So for every single order ID that gets created, who was the user that created it, what was the total amount, what has been the status, so whether it's been charged or refunded or delivered, or you can put all sorts of values over here. And then same way for the order items, what was the order ID, for each of the order ID, what is the product ID associated with that, how many quantities, and what is the price point. And then you can have you can create all sorts of invoices based on that. You can also send out notifications based on that, and you can query users saying that, hey, you purchased this at this time. There is a very high likelihood that in the future you would buy something similar, so let me show you the things on the main shopping page based on that. So it can be handy in a lot of scenarios. Plus for the auditing, this is really important. Also, in terms of sample APIs, we will have a simple post orders API that you should be able to post orders, and then you work out the checkout, or you can get the details of any particular order based on the order reference number. Payment services, once again, important, quite straightforward, and DB choice is quite simple. We need to use a SQL DB just because of that very strong consistency purposes. In terms of table, we will have our simple straightforward payments table that has the payments ID, order ID associated, that what was the order ID, and then what was the payment method. Did we pay through like points, or did we pay through card, debit card, checking card? Maybe it was a split payment, whether the payment has gone through or not, what has been the transaction ID, and when this payment was created, and things like that. So we can do that. And APIs is we should be able to charge for payments, and we should be able to provide refunds. So if someone is not satisfied and they needed to have refunds, once again we will use the same instruments of charging person through those third party vendors or banks, and either get money from their credit card or post money to their credit cards. Lastly, it's sorry next it's review and rating service. Once again, pretty standard service. So we should be able to user should be able to review products and provide their ratings. And we are going to have a simple reviews table. It's going to be a relational DB that we can prefer over here. We can also use a document based database over here, so it's up to you. Both would work in similar fashion. And then we can have a reviews ID, user ID, that who was the that provided the ID, what was the product that they purchased, and then what is the rating, what is the comment, and when it was created. Maybe if you want to add more functionality, that there can be sub comments below the existing comments, and then that would make the reviews more complicated, but still like one of the functionality if you want to discuss with your interviewer. Core responsibility is quite straightforward, like store users reviews and ratings, and then it aggregates the average ratings and update for any particular products. So based on that, we can put it in the algorithm to show that which products to show first whenever some users start typing about some items. And sample API is once again a simple get and post API to post reviews and get reviews for any particular product. Next one is our notification service. So for that, we can use a keyword based database if we want to, or we can also use a relational DB as well. So it's up to you, whichever you wants to pick. Entities are going to be quite straightforward. We will have our notifications ID, because every single notification that we are sending to whom did we send those notification to, so that's why we have a user ID. And how did we reach out? Maybe it's email, maybe it's SMS, maybe it's in-app notification, whether the sending was successful or failure, whether it was something that we were actively keeping track of, that whether it has been sent or it's just shoot and forget, because many times we would be having those notifications that are just shoot and forget and we don't care about them. Or there can be some notifications that are really critical. Let's say if I'm trying to do an MFA or two factor verification before I charge someone for the thing that they are about to purchase, I want that to be consistent, and always check the status that whether the user has received the notification and whether they have completed it or not. As if something else that is like, hey, this TV is on sale, and I want to send out notification to that. And some people can just look at it or not look at it, and because I'm sending a mass notification, even if it does not reach some people, I don't really care that much. So the based on the type of notification, you can define the importance of the notification. And in terms of responsibilities, it's quite straightforward, sending out emails or push notifications. And there is going to be a pop sub mechanism over here. So different systems should be able to publish the events that they want to send out as notifications, and then we can create like a Kafka or event hub based system where notification service gets these events, and the moment it gets it, it just pushes the notifications based on the input parameters. So yeah, this is going to be that what is the type of notification you want to send, who is the recipient, and what is the message. This is a simple notifications API, that's a post API. And for analytics service, we don't really have much APIs in this case, because it does not make sense. It's more about what we are trying to achieve. So we have mass amounts of data. We need to first of all store it in some warehouse, maybe some data lake or something that is cheaper to store. And then we are going to query it. We can do like a extra ETL or ELT transformation, and then show it to maybe data team for LLM training, We can also do like some business insights. We can create different dashboards for different users, maybe for sellers, maybe for company executives, maybe for just to keep track of how the systems are behaving and things like that. So there are all sorts of usage that can come out of the analytics service. It's a very complicated service in my opinion. So it's not easy to create low level design, especially in 45-minute interview, where this is just one of the 10 services that we are discussing. I can do like 1 hour video just on analytics service as well, and which we would do at some point eventually. So this is the summary of the entire thing that we just discussed, that these are all the tables that we are going to be talking about, and this is what their common table looks like, and these are going to be the fields that we would be worried about. So this is the entire low level design. So, how did you like me designing the e-commerce platform, something like Amazon and eBay? This was my first attempt at a big long-term system design video. So I would be making like about 100 of these videos, and I want your support to understand that whether I'm going on at the correct pace, whether I'm going at the correct speed, whether I'm explaining things clearly, or is there something else you want me to see. So please make sure that you provide your feedback, because this is just one of the 100 videos that I'm going to make. And the earlier you give me more feedback, the the more improvements I can make along the way to make better videos. And once again, I'm extremely grateful. We are very close to hitting 20,000 subscribers. I don't know, we might hit when we actually upload this video. So all in all, I just want to say like very much thank you, because 2 years ago, 3 years ago, I didn't knew that there would be like 20,000 people who would be willing to follow me. So once again, I'm just like extremely grateful, and thank you so much for all the love and all the gratitude that you guys have shown me. Once again, if you enjoy this video, let me know in the comments what do you think about it. And meanwhile,